Here in our first episode, we're going to go through things that I, as a teacher who's taught chemistry for a long time, don't really understand, and what I do know and what I don't know. First one we're going to do is we're going to look at orbital diagrams. And specifically, when I say orbital diagram, I mean when I draw the picture of this with the arrow representing an electron, I have several questions that I don't know to this point that I would like to kind of put out there, and feel free to kind of chime in if you're highly educated on those things. So I know that this arrow represents an electron, the up represents its spin quantum number. The line, how high it is, represents the energy, and specifically it represents the energy of that particular electron interacting with the nucleus. And I also believe that it's also interactions with the other electrons present within that molecule or within that atom, mostly within that atom. So the reason I believe this to be true is I think that these vary based on other electrons. So other electrons coming into the system cause this to change the heights, and that causes us to split between 3D and 4S and things like that. And then I know that the number of protons will obviously have an impact on what the energy of a single electron is within an atom. Okay. What I don't really know, first and foremost, is what does this mean? So when I say it's the energy, is that the electrical potential energy? Is that the kinetic energy? I assume that's not it. But also, is it both? If it is both the potential and kinetic energy of that electron, how does that vary? Or is it constant? Meaning this. So if I have an electron that I'm looking as it moves about within an atom, there's some very tiny nucleus there, that is obviously the electron can be in different positions. We've all seen those wave functions described where the radial position changes. So as that electron changes, how close it is to the nucleus, is it just like a typical orbit where we see that as the electron gets closer to the nucleus, let's kind of exaggerate that a little bit, that it's faster here and slower here, and there's a trade-off between the potential and kinetic energy? Or do we not know at all? Is there no way for us to be able to track what the single electron is doing within an atom as it moves about? And the only thing that we can do is look at how an electron transitions between these electronic states and look at the light given off for that. Or is there a way for us to come in here and to make a measurement on that specific electron? Now, to be clear, I'm fully aware that if I have a 1s and a 7s electron, and I know they're interchangeable and all that jazz, but the 1s electron is faster than the 7s based on the fact that it's closer to the nucleus, it experiences a greater force, and therefore has greater acceleration, greater velocity. I know this is faster. My question is that 1s electron varying its speed? So as it changes its location within that 1s state, does it change how fast it's going, and does that change correlate to how far apart it is from the nucleus? So I know that the Hamiltonian has a potential and a kinetic. I don't remember the kinetic energy component of it, whatever that is. That's that complicated h bar, whatever, squared something. I know that the Hamiltonian, the energy describing an electron nucleus electron system, is equal to these two components. When we do calculations on those, do we expect this to remain constant and these two to vary within that system? Do we expect the potential to remain constant? How does that work in terms of having a static state of electron, where an electron has a defined angular momentum quantum operator and a defined angular momentum quantum operator and a defined energy state? How does that fit into that two-component system? I don't know, and I don't really understand. And then beyond that, how do we know? So I have an understanding that if I have a state, and the electron moves from one to the other, there's going to be light absorbed or emitted on the way back, and we can look at that light. So we can look at light absorption, we can look at light emission. But is there a way for us to go internal to look at an electron while it's in an atom? Obviously, there's huge issues with electrons in terms of the uncertainty principle. And I'm aware of that. What I'm not aware of is, does the electron being within the atom itself lock that in somehow, where it increases the uncertainty principle measurements, or where it makes it where it is possible to measure to get reasonable amounts of information. So can we come in here and measure the position of the electron time and time again and use that to match to a probability distribution, where we're just assuming probability distribution and coming back and looking at how much light there is in exchange for this. And if we look at that light, how does that band or the frequency kind of vary? So when we go and we look and we say, okay, we're expecting, this is the frequency of the light, obviously we're not going to see just a single line, we're going to have some band gap or band widening. Okay. And do we make predictions about why that widening occurs? And then how do we go through and confirm our predictions for that when we look at this whole system? So at the end of the day, really what I want to know as a teacher is, how does an electron move within an atom? And how do we know that? What I have a hard time in particular with is that a lot of times when I look for this answer, I find a lot of mathematics where we're making assumptions about how the nucleus is stationary or how there's a trade-off between these various things, which are hard to understand, but they're also hard to go, well, is it the mathematical prediction, and then are we seeing that that's correct? Or is that an actual mathematical description of what's happening that we've found out through some form of measurement? Is that kind of well, we can't see, so we're going to guess and then see if we were right? Or are we saying, oh, we saw this, and therefore we're mathematically describing what we saw here? So at the end of the day, what do we know about how an electron moves within an atom, and then how do we know that? What's our evidence base to figure that out? Is really what I am not feeling very confident in, even though I feel like I know a chunk of information about when I'm looking at what an electron does within an atom. So if I come back here, I have some understanding of what I'm doing when I do this, but I feel like I'm missing gaps, and they're important gaps into kind of having a full, deep understanding of the whole thing.